Welcome to 4.10's Math Moment. Today students learned about how to round decimal numbers to help them estimate when they're multiplying with decimals. So let's take a look at some examples. Example 1 says round to the nearest tenth. So the first thing the students did today is just practice their rounding skills. Something that's really important to remember when they're rounding is anytime you have a 0 to 4, you're going to stay the same. And then if you're working with numbers 5 to 9, you're going to add 1 to the other number. So that'll make sense here in just a minute when we work on this example. Alright, so it says round to the nearest tenth. The first thing that you need to do with a number when you're rounding is identify the place value that you want to round to. So we need to round to the nearest tenth. This number is in the tenths place, the 7. Now, the 7 does matter, but the more important number to help us round is the number that's to the right of the 7, which is the 8. Alright, so we always tell students to look at the neighbor to the right and even circle it, because that's the number that we need to use these reminders with. Is 8 between 0 and 4 or 5 and 9? It belongs in between 5 and 9, so that means I add 1 to the 7. Alright? Then I'm going to add 1 to the 7, which makes it an 8. Everything to the right changes to zeros. Everything to the left stays the same. Right? When we finish rounding a number, I like to ask students, does that make sense? Is 782 thousandths pretty close to 800 thousandths? And the answer they should give me is yes, that is pretty close. When I'm thinking about cents, also with money, if I think about 78 cents, is that pretty close to 80 cents? Absolutely. So that's another number or another way to look at those numbers and to think if your rounding made sense. Alright, so another example and different type of problem that I looked at today was finding the estimated answer of a multiplication problem with decimals, then finding the exact answer to help them see that estimating the answer can help them decide if their real answer is reasonable or if it's close. Alright, so when I'm looking at these two numbers, they have, and it doesn't tell me where to round to. Like up here it told me to round to the 10th. Here it doesn't tell me, so I need to see what they have in common. I could round to the nearest whole number because they both have a neighbor behind. They both have a number in the tenths place, but they don't have a neighbor, they both don't have a neighbor behind, so I probably just want to round to the whole number this time. So when I look at the neighbor next door, let's focus first on this one. Is it between 0 and 4 or 5 to 9? 7 is between 5 to 9, so I'm going to add 1 to the 6. Everything to the right turns to zeros. Everything to the left, if there was anything there, would stay the same. And again, I ask students, is 6 and 7/10 pretty close to 7 wholes? Yes, so we estimated correctly. Here I'm going to look at 3. Is it 0 to 4 or 5 to 9? 3 falls in between 0 and 4, so my 8 gets to stay exactly the same. Everything to the right turns to zeros. If there was anything to the left, it would stay the same. Now, when I have two numbers behind a decimal, that looks a lot like money. So then you can again have them think of money. $8.34. If I had that jingling in my pocket, is that pretty close to $8? Yes, it's closer to $8 than it is $9. So that's why we rounded to 8. Alright, so here, now this is a really easy problem to solve because it's just 7 times 8. Well, 7 times 8 equals 56. So when I do my exact answer, the exact numbers that are shown here, my answer should be pretty close to 56 if I multiplied correctly. So let's go ahead and work that out. I'm going to move it up here for room, 8 and 34 hundredths times 6 and 7/10, which was the original numbers that we have. Now remember, if students get a little bit thrown off by those decimals, they could just think of this as 834 times 67 until we put the decimals back in at the end. So 7 times 4 is 28, carry my 2. 7 times 3 is 21, plus 2 is 23, carry my 2. 7 times 8 is 56, plus 2 is 58. Now, I'm done with the 7, so I X it out so I don't get confused. I also X out anything that went with the 7. So those 2's up top, I want to get rid of as well. Anytime I make X's up above, I need an O down below. And now I can distribute the 6. 6 times 4 is 24, carry a 2. 6 times 3 is 18, plus 2 is 20, carry a 2. 6 times 8 is 48, plus 2 is 50. Now I need to make sure that my numbers are all lined up, so it's easy to add. 8 plus 0 is 8, 3 plus 4, 7, 8 plus 0 is 8 again, 5 plus 0 is 5, and then this 5 is all by itself, so it just comes down. Now, this is not my final answer. I have to go back to my original problem and see how many total numbers are behind my decimal. In this problem, there are 1, 2, 3 total numbers behind my decimal. So I need to write 3 total numbers behind my decimal in my problem for a final answer of 55 and 878 thousandths. Now, students might look at these two numbers and think, those are not close at all. This has a lot more digits. This doesn't have a decimal. This one does. But when you really focus in on the number, these are very, very close. This number is 56 wholes. This number is 55 wholes with 878 thousandths, which with a decimal piece as well. But if I were to round this, it would be 56. All right, so we did our multiplication correctly. I know that because I estimated, and both of my answers are very close. If you have any other questions about lesson 4.10, make sure to see your math teacher.